Okay, good. Uh, yeah, so Simon asked the easy question, so I can see that almost half, or maybe even more than half of the room know about Sigfox, but how many of you understood who we are and what we are doing? Yeah, okay, I can see a little less hands, so maybe I'm not doing my job good enough. To introduce me quickly, so I'm at Sigfox since a little more than 2 years. My job is to drive the adoption of the Sigfox technology, Sigfox service, all from a technology point of view. So I won't be able to deliver you a sales pitch today. It will be more technical focused, but trying not to get too deep into details towards everybody. I think we'll have time for Q&A either at the end of the presentation or later on around some pizza and beers. So feel free to ask anything afterwards if you need details. You've got my contact information, anything needed here. So, to say it briefly, Sigfox is a communication service. It's a technology, a radio protocol, and so on, used for this communication service. We are not pushing down a technology for you to integrate and do whatever. It's a service that we offer, is ready to use in production, right now in a little bit more than 30 countries. So mostly Europe, South America, Asia, Africa, getting there, and so on. I will detail you what low energy and simplicity means in our own context. Those are the main focus of the technology and the service. So all the choices, the design choices, the architecture choices, have been more towards energy efficiency, simplicity, and so on, to make sure that everything, not even connected objects, but anything, any dumb thing around us, is able to send some small but important information around for very little energy cost. Because in the end, energy is a lot of money, and it's pretty easy to have projects that just don't fly because you spend way too much energy to send useless data. Okay, let's get into some details. So this is what Sigfox looks like. Basically, you have a bunch of devices doing what they need to do, waiting for an event to happen, or measuring some environment value every 15 minutes, every hour, every day, depending on the use case. So it could be, is my water tank is full, empty, half empty, and so on. It could be an event, if the door being open, if the temperature above the security level, magnetic field, whatever. A lot of use cases I could detail afterwards. So all your objects will send their data, depending on the use case, and messages are picked up by your own network. So when I said we are not pushing down the technology for you to integrate, it means that it's not up to you to set up these receiving stations to deploy on your own private site or to build different networks that will compete against each other. You will have in each country exclusive operator, which is in charge of building up the infrastructure. So in the UK now, it's WND who is taking charge, taking the lead after Arkiva, which was in charge over the last few years. So setting up base stations around, waiting for signals to come in. And then through our own cloud, depending on your own configuration, we push the data down to your own application server up the way you like it. And you can, of course, go both ways. So up, what we call uplink communication, so up from the device to your own application server, or down from your own application server to the devices. So it's small messages, no security camera broadcasting over Sigfox. Please don't try that. It's about a few bytes of data, up to 12 bytes, 140 times a day. So it's not about opening a data socket which stays open to exchange data back and forth. It's really for sensor information. Very small information every now and then. So this is where the service is available right now. So of course, it's pretty convenient for us to paint the whole countries in purple, but you also have what not everybody is doing. You have online the detailed production coverage. So all the purple countries are being under-allowed. You can guess that for Australia, Brazil, or the US, we are first focusing on the, let's say, useful areas where you have population, where you have business. So right now, Australia, for example, almost all of the population is covered, but a very tiny fraction of the desert is covered. I have a zoom on Europe. So this in blue is the live service which is available right now in Europe. It's one network. I was speaking earlier about operators, but it doesn't matter for you as an end user. A device that communicates here in Scotland can move to Paris, where I came from earlier today, and works exactly the same. No other contract issues, no roaming questions, and so on. It just works. From Portugal to Denmark, through the UK, Germany, Italy, whatever, you can either ship your solutions across the world to your different customers, or if you have moving solutions, let's say asset tracking, you want to monitor deliveries, shipments, pallets, whatever, it can move all around and keeps working exactly the same, seamlessly. And I zoomed over the UK, and picture is cropped, unfortunately, but you can see that UK is not yet as well covered as other countries in Europe, but it's moving forward, especially for Scotland right now. You only have coverage around the Glasgow and Edinburgh areas, and if I speak fast enough, I may have time to show you that it really works today. So this is I'll try to get fast on that, but try to focusing. IoT means a lot of things. It can mean bullshit a lot of the time. What we are focusing on and what we are good at are industrial application, be it what you can call Industry 4.0, predictive maintenance, and so on, agriculture, security, asset tracking. So not the fancy gadgets that you'll buy on the online shop that you wish or that you will back on Kickstarter, but mostly industrial application, business applications. So not the sexy, fancy devices, but the applications that quickly add values, improve businesses, make some money, which is usually pretty good. So it's this part of the iceberg, the one that nobody wants to see, that nobody will want to hear about your IoT business, because you are tracking waste containers, you are monitoring railway tracks, that kind of stuff. But it's useful, and it's the real IoT today. That's where things are happening right now. Most of the few millions of devices that are on our network right now are here. You will have some B2C solutions, of course, but that's not the volume. The volume is here on the B2B or B2B2C or whatever you want to call it. So today, detail a little more the technology. So the protocol which is underlying the Sigfox network. Key parameters it's as simple as it gets. You have no connection per se. You have no negotiation with the cell tower. You don't have to ask the network when you can communicate, on which frequency, which channel, that kind of thing. It's really the other way around. The network is not disciplining the devices, but the network is here to serve the devices. So the device is the master of every communication, which means that you just power on your device, it sends its data, and the job of the network is to be ready to pick it up. There is no synchronization beforehand. All of that is made to optimize energy consumption, because it takes way less time on the air for the device for a successful communication, less energy consumption, longer battery life, lower total cost, and so on and so on. So no signalization channel, no pairing with the cell, no handover, nothing like that. Just broadcast your message and let the base station do the heavy lifting. So to throw some numbers, when we say low energy, depending on the chipset that you will be using, you can use chipset from various partners, from ST, Microchip, formerly Atmel, on a smaller one like module makers that you have all around the place. You can check them online. Consumption will vary a little, but you will stay in the tens of milliamps during the few seconds of emission. So between 15 milliamps and 50 milliamps in Europe, roughly, depending on the solutions. So this is during the 5-6 seconds of emission. The key factor is that 99.9% or even more of the time, your device is just doing nothing. It's not connected to the internet with an IP connection, something like that. So you don't do anything, so you don't burn energy. That's what allows devices in production to have battery life of 5-7 years, depending on the solutions. Communicating close to nothing, a few microamps, even down to 800-900 nanoamps on the latest solutions. So you get long range of communication between a few kilometers when you are in urban context, difficult propagation and so on, to tens of kilometers in the countryside when you have flat countries and so on, and up to the horizon or even more than that when you have very favorable conditions. The current record that we have is from a tracking company. Is doing some GPS trackers and using them on boats. That the message is sent from islands, from the southern coast of Ireland, that have been picked up on the northern coast of Spain. But that's not what will happen on daily basis. It's just what happens when everything fits well. But we don't overpromise. But when we say that you'll get reception to 30, 50 kilometers in the countryside, that's a reality. That's not just a marketing claim or some bullshit. That's something that you can just check right now for yourself in production. So yeah, I was saying early on, small messages. So I didn't forget any units. I come from a web background myself, so I was used before Sigfox in sending megabytes of useless data, JSON, XML, name it. Here it's down to mostly computing like in the 80s, getting down to binary stuff, using as little energy as possible to describe, as little memory as possible to describe your data. Because again, the smaller the message that you send, the smaller the time that you will spend on the air, and the smaller amount of energy you will consume, the longer the battery life, and the less energy the less maintenance costs in the long run, and so on. We are using very slow data rate because we have a very small power output at 25 milliwatts in Europe, and to get tens of kilometers of range, we cannot do that on a high data rate. So in Europe, it's 100 bits per second. So every byte that you send or you don't send has an impact on the communication time. So hopefully I will be able to show you what it looks like live. This is the radio spectrum of one of our base stations in production. So right now, so we are using what we call unlicensed bands, which means that we don't have to pay billions of fees to use dedicated radio bands like 3G, 4G, for example. But it's shared spectrum, meaning that everybody is allowed to use those radio frequencies, so 868 megahertz for us, for free. Be it us, be it other radio solutions, be it scientific application, medical applications even, radio amateurs, whatever. So you've got a lot of what we call undesired signals. So all of that is activity which is not proper to Sigfox, but that our stations have to cope with. And this is a Sigfox messages, like small spikes in the spectrum on only 100 hertz wide. So there is no channel per se. So within this 200 kilohertz part of the spectrum that our stations are monitoring all of the time, you can have close to 2,000 possible frequencies at the same time. So this allows for high capacity without synchronization, because each device will send its message on a pseudo-random frequency within this range with 2 repetitions, which help the stations detecting them, collaborate between the stations, and offering a guaranteed service level without any pre-synchronization mechanism in place, and so on. This is what makes the offer quite unique, is the ability to guarantee service on unlicensed bands, so with a very low cost of operations, and without useless synchronization or communication going back and forth and tampering your battery in the end. Hardware solution, I'm sorry, I'm going quite fast through it because I really want to make room for a demo without eating the time of the other speakers. So hardware solutions, I don't know if a lot of you are into hardware. Yeah, so basically you can use either off-the-shelf modules. So our module is the radio part, the MCU, all in a box, ready to use how you wish. Put it on your PCB, plug an antenna, and let the magic happen. It should be okay. So modules right now, you can get them starting at $2, even lower than that, without MOQ, with an MOQ of 1. Or you can even build your own solutions. You can do your own solution using your own transceiver, your own MCU, because maybe you have a legacy device that you want to upgrade, or you want to retrofit whatever solutions you already have in the field, or you have very custom needs. This will cost you a little more time and energy because you will have to integrate our own binary, going through certification and so on. But to make it short, right now, starting from $2, you can get a functional module available and get started in a few weeks. Either from major companies like I mentioned, or smaller module makers like Wisol, Inocom, Telecom Design, Telit, and so on, or all the big names that have radio-compatible solutions available from TI, ST, NXP, on, Semtech, even if they don't like a lot to talk about that. They've got a chipset which is perfectly compatible, and modules are coming along the way. It's expanding a lot, but your provider of choice most probably already have a Sigfox ready solution available for you without you doing all the work again and again and again. So service means it's not only about the hardware. So this is nice, but the offer that we have is that we also receive your data, process them, and give them out to you. So either you want to just have a look at the online portal to make sure that your first Hello World has been received. This is what I will show you afterwards. You can synchronize your applications, your database, your proprietary applications, whatever, using a REST API. So it's all standard stuff. But the mechanism that we recommend is what we call callbacks. So other companies would call that webhooks, whatever. It's a push mechanism, meaning whenever one of your sensors in the field out from the thousand that you have will send a message, we will forward this message alongside some metadata, so who the device is, when the device was sent, where was it received roughly, and push it down to your own application, but push it down your way, meaning that you don't have to do custom developments to ingest the Sigfox data, but tell us what do you want to receive, CSV, XML, your proprietary format, and we will push it down to you. And within a couple of seconds, your device will have sent a message, you will have received it, and you're able to do whatever you want. Trigger an alarm, place a phone call, just update your database, alert your customer, send back some data to your sensor because maybe you want to shut down the water valve because you received a leakage alarm, and so on. Yeah, so that was the callback slides. So thank you for listening to me. I know my English is far from perfect, and I'm often speaking too fast. You got plenty of links with details. I'm available to give you some more info, and I will try to do a demo. It worked before, I promise, and usually when I do them on stage, it fails. So please be nice. Basically, the point is trying to show you that it really works. So what I will try to use first is just a USB dongle. So a USB dongle with a Sigfox module in it, and send a message with it. Okay. Okay, hopefully you are able to see something. Okay, so basically I just connect to the USB dongle and I can send him IT commands. So for those of you who worked with old modems or some cellular stuff and so on, it's pretty standard. So a set of attention commands to just send your instruction to the module for it to send the message. So it's ready. And if I want to send a Sigfox message, it's as simple as saying, okay, attention, send frame. And I've got then up to 12 bytes. So in hexadecimal, meaning I can send 0A, 1, 2, 3, 4, cafe, because I'm quite tired at the end of the day. And now it's sending the message over the network. And here it is. I don't think you can see anything. Okay, I'm sorry, I never remember how to zoom. Okay. Okay, so this device, I know him because I tested earlier, is called 1D28 unique ID on the network. It doesn't have an ID address or a MAC address. It's a Sigfox ID. So this one is pretty small because it's a very old device. I think it's something from 2012, back when we started. So I've got some information about it. I'm on the Sigfox portal. And when I check its message, okay, I don't know if you can see it. Yeah. So you can see that we received at 8 p.m. This is French time. It's not being sent in the future. I didn't fake it. So it should be 7:11 here. So we received the array 1234 cafe. It has been received by 2 stations with a received signal strength intensity of -132, -117. For those who are into it, sensitivity of the base station can get as low as -142 dBm. So this one is pretty good. -117 means that we have a station that's probably pretty close. So some details about the detailed frequency and so on. Don't get too excited. You don't have access to this detailed information when you're a basic customer. I've got it about the detailed frequency, but all you care as a user is that the message has been picked up. How it has been picked up, it's our job. My job is to explain you that it's not just magic and to show you how it works. And using the API, I can even ask where it has been received. So it's not this one. So I thought it was 1D2A. Okay, so this message has been picked up by 2 stations in Edinburgh. So I'm not very familiar with the place, but basically you should be more than me. So there is one which is near the golf club in the west. I don't know how far it is. And what's interesting is that you can see this is only a demo device that I use from time to time. So previous test was when I arrived, just to make sure that it works. But before that, I used it in Germany. It was not received in Berlin and Munich at the same time. There's a station that was not located properly in the system. But it worked in Germany, it worked in England, and before that, most probably in France. So the same device with the one contract can move around and just works and is received exactly the same way. You don't have to bother with complicated stuff and so on. It just works. You already have a lot of work in IoT in finding something relevant to say from your device. It's really a hard job. The job of how to say it, how to transmit the data, we do it. Focus on finding something to do, finding something to say, and do something with the data. There already a lot of hard work on both ends, not to be bothered by losing time on the communication part. That's why I try to insist on the simplicity part of the solution, is that you can guess that something like that, it won't be really hard for one of your developers to come out with that and being able to extract. Let's say in this context, 0A means a lot. In a few days, you will have a proof of concept that sends this data over Sigfox to your application servers, and for you to try to do some graphs, exploit the logs, and so on. So focus on where you have added value, and don't lose time and money on parts that are secondary to your business priorities. Speaking about money, we are nice guys, but of course we're not doing that for free. So the whole business model is not on selling out the chipsets. We don't get 1 cent from ST or from Microchip when you buy out solutions. Where we get our money from is from subscriptions. And subscription price ranges roughly, depending on your volumes and so on, but it ranges from €1 a month per device to €1 a year per device. That's it. So I'm not good at currency conversion versus the pound. It should be a little less than that. But very small subscription cost. And the whole point for us is for you to do millions of them. Of course, this works only with the high volume that we all expect from the IoT that are getting there. We are still speaking about millions of devices today. Everybody likes to play with the analysts who speak about billions. The billions are not there yet, but we can see ramping up over the last 18 months. the volumes are starting to really ramp up, and that's where our business model makes sense. That's it. So I'm pretty happy that my demo worked, so I won't risk a second one. But basically, this is it. It just send something, receive it on the other end, and do something with the data. And you can, in the same way I sent a message, I can ask the network, do you have an update for me? Which will tell me, switch your operational mode, switch the frequency of measurement, shut down an equipment because something is faulty or because the customer is not paying anymore, whatever is relevant for you. We don't deal about the complexity of your use case. We're here to help you build it up, but we're just here to take the data that you extract from your environment, from your own use case, and transport it to the other end. So basically, this is it for me. I don't know if we have time for Q&A right now or if I already spoke too much.